I'm going to rewrite it down here. X equals the square root of 5x plus 6. I have to square both sides. So I get x squared equals 5x plus 6, because these perfect square root and the square cancel out. So minus 5x minus 6 minus 5x minus 6. X squared equals x squared minus 5x minus 6 equals 0. So then I factor with the AC method. So I'm going to go A equals 1, B equals negative 5, C equals negative 6. So I go AC 1 times negative 6. And then B equals negative 5. So then I get negative 6. And my factors will be negative 6 times 1. So when I add them together, negative 6 plus 1 equals negative 5. So then, let's see, we're going to expand this right here. So then x squared minus 5x minus 6 equals 0. X squared minus 6x plus 1x minus 6 equals 0. X and then x minus 6 and then plus 1 x minus 6. Your linear factors are going to be x plus 1, x minus 6 equals 0, x equals negative 1, x equals 6. So we're going to do true or false to test our solutions. So true, false, because you have to test the solutions back into the original equation. And the original equation is going to be, again, in the green. This is what we're using, and these are the solutions. So then we go 1 equals the square root of 5 times 1 plus 6. 1 equals the square root of 11. This is false. And then we do 6 equals the square root of 5 times 6 plus 6. 6 equals 36. 6 equals, the square root of 6 is 6. So this is true. So the only solution is 6. And this is for number 4. The domain and range of the relation, write your answer in interval notation. Interval notation is where you have like the soft brackets or parentheses. I'm sorry, the hard brackets or the soft parentheses. And it's based on the inequality. So let's go ahead and do this. So the domain, you're going to take whatever is underneath the square root, and you're going to say that it's greater than or equal to 0. So 2x minus 5 is greater than or equal to 0. And then we're going to solve for x. So we add 5 to both sides, and I get 2x is greater than 5, and divide 2 by both sides. So then I get x is greater than or equal to 5 over 2. So as interval notation, it's going to be 5 over 2, bracket 5 over 2, comma, positive infinity. And then for the range, we're going to need to look at the graph of this function. So the graph of this function is going to start at 5 over 2, comma, 0. And since we're looking at the function, we're looking at y's. Nothing is stopping that function from approaching the y's. Like, the y's go this way, and nothing's stopping it. So that means that our function is true for, or it's possible for all valid y values. And so in an interval notation, here's what it looks like. It's going to be bracket 0, comma, positive value. F of negative 9 for f of x equals the piecewise function 243 divided by x, or x to the third minus 3x. So you have to see where the this negative 9 substitute for x, and you have to see where the inequalities are true or false. So we're going to go ahead and do that. So again, we know that x equals negative 9. We're checking for true or false of the inequality. I know this one's true because I'm going to set it up. So if I have x is less than negative 3, if I substitute the x for negative 9 is definitely less than or equal to negative 3. So now that I know this is true, I'm going to substitute the negative 9 into the 243. So 243 divided by negative 9, right? So 243 divided by x now becomes 243 divided by negative 9, and that becomes negative 27. So that is a possible solution. And then just to check our work, I'm going to assume that the second one is false because you usually only need one true. So for this one, what you're going to do is x is less than negative 4. We're going to assume it's false. So negative 9 is less than negative 4, which is false. And that doesn't work. So the answer is negative 27. Excuse me. Negative 27.